In this question, we're told that water flows in a pipeline A, which has a diameter of 150 millimeters, at a rate of 0.02 meters cubed per second. So we're told the volumetric flow rate. And then this pipe branches into two smaller pipes, one which is 100 millimeters in diameter and the other that is 50 millimeters in diameter. We're then also told the velocity in the smaller pipe, which is 3 meters per second. And we're asked to find what is the velocity in the larger of the two branches. So this question is basically continuity. So for incompressible flow, because we've got the same fluid going in and out, we don't need to worry about the density, so we don't need to work out the mass flow rate. We can do it all on the volumetric flow rates. So the sum of the volumetric flow rate going in has got to equal to the sum of what's going out for incompressible flow. What goes in must come out. So the volumetric flow rate into A is equal to the volumetric flow rate going out to B and D added together. Now in the question we were given the volumetric flow rate of A, but we weren't given the other two. We were just given the diameters and one of the velocities. Okay, so we know what the two diameters are, and we were told what the velocity in B was, but not in pipe D. So by rearranging and making the velocity in pipe D the subject, we can then plug in the values, remembering that we've got diameters, so we need to work out the areas. And if you do all that, then you should come out with an answer for the velocity in pipe D of 1.8 meters per second.